Okay, let me make sure I have everybody. So for starters, um, final exams are next week, right? It's so fast. Eh, So I have actually gone through and actually finished Connect 4 on here. I'm going to walk us through it. Um, Otherwise, we're gonna not have enough time to do some stuff. Um, in any case, um, we're gonna talk about that today. I do want to actually share something a little bit interesting, geeky computer science stuff. So, how many of you are familiar with the AI model from Meta called Llama? So, Llama is effectively Meta's version of ChatGPT, except it's open source. You can run it yourself. And you have to have a pretty big server to run one of their larger models. So at my house right now, I'm running Llama 3.3 70 billion token, which is basically taking up all 24 gigs of VRAM on my GPU. So it's pretty much the most you can run as like a normal consumer on your computer until you start building purpose-built AI machines and stuff. But in any case, what becomes fascinating is when you run your own large language model like that, you can turn off like ethics filters. So you know how sometimes you'll be on ChatGPT or similar and you ask it to do something, make a picture or something like that, and it starts complaining against that's against terms of service or whatever. Well, you could turn that off if you're running it yourself. Well, it starts becoming very interesting depending on the direction you start asking questions that in some ways it's racist. And when you really think about it, these things are they're trained on, we say they're trained on the world's data. Well, if we think about the entire world population, I'm just making up numbers here, but doesn't it seem reasonable that something like 95% of all the world's digital information is probably created by 20% of the population? We don't have these tribes in Africa creating digital data. So it's not being trained by a representation of the whole world's population. It's being trained on a small representation. So depending on where they get their data from, it the models can be biased in a certain direction. Um, yeah, really the example where it became obvious, I can't even tell you about it. It's that bad. But believe me, if I say it can get really racist.
Say what you were like asking for, if for, or
Say this again.
like, what were you? Can you say what you were asking?
Okay, so it got down a path where it starts getting into like Nazi stuff. And then it kind of took it from there.
We can see a little creepy.
Huh? Oh, yes. That's hilarious. Well,
He's not getting it from you.
no, no, no. So I was trying to ask it, I wanted to see where the boundaries were. So I was asking it like historical information, like about the Auschwitz concentration, you see it on there, concentration camp and stuff like that. And then, asked it to do creative like writing with that topic in mind. And some of the places it went with that were real sketchy. Yeah, like that large language model, I think would have made a pretty decent SS officer. So I guess what I'm getting at. But it is fascinating that they do. So like when you use ChatGPT, you can pretty quickly it pretty quickly will start yelling at you that you're trying to even if you just say, make me an image of Deadpool, stuff like that. That's against like copyright and whatever. It'll yell at you. When I turned it back on and I fed it I restarted it so it didn't have the same memory in there, and I started feeding it the identical prompts, like two prompts in, it basically says, started giving me um, warnings that this is probably not something that I can talk about. Keep in mind this was an atrocity, and but just really fascinating. So it made me consider when you have these public models like ChatGPT, sometimes some of the training wheels they put on there can feel frustrating. But then you think about the alternative, like, oh, why don't they just turn it off? Well, these things could be abused pretty badly. And it kind of gets down to the debate between Elon Musk and Sam Altman. You know, they were the founders of OpenAI, the ChatGPT people, and then they had a falling out. Elon Musk created the Grok thing through X.ai. Sam Altman's going down with the ChatGPT side of things, and Elon publicly at least thinks there should be more checks and balances, safety protocols. Sam Altman thinks there should be something within reason, but let's still chase general intelligence and then go watch the Terminator movies and just see what happens. Um, but it really was fascinating, and I had like files saved with the prompts, and like I put in the name of the file, "Do not share this," so I didn't accidentally send to people. And believe me, if I'm rejecting something, it has hit a new extreme. Um, all right. So, anyways, that was the interesting geeky thing from the weekend. All right. So let me first quickly dive into the online GDB. I went in and we had a couple of errors there at the end of class. I went in and fixed them. I put a little some comments in there that say where the issues were. So it was inside of our Connect 4 board, our check for winner, specifically the diagonals. Let's see. Here are some of my debugging things. Online GDB doesn't allow you to use their debugger with C#. So I had to just put printlns in there to see where it was dying. So some of the things that I had to change. So for example, the Boolean expressions in a couple of these for loops, I had I changed something being greater than or equal to 0 to being less than the number of rows because we were moving in one direction, but I was checking on the wrong edge. So in this case, J is the rows, and if the rows is going up from 0 to 1 to 2 to 3 to 4, it's going to be an infinite loop if I compare it against greater than 0. It's always going to be greater than 0. So I had to make sure I didn't run off the end of my number of rows, things like that. So I fixed that on there. I had to do something similar somewhere else, but actually the core issue was in, where did I mark that? I think it was in this area right here. So when I get the current checker, when you're doing the diagonals, I had it hard coded for the row, where the row was where you dropped it, what the top row is, not the current checker we're looking at. So that worked, having it hard coded for row or hard coded for column when we were dealing with horizontal or vertical. But when you're doing diagonal and both of those things are moving targets, you have to make sure you're operating off of your counter for it. So that's where the couple of errors were. We were accessing parts of the array that didn't exist, either from Boolean expressions or having hard-coded rows and columns, whatever in there. Otherwise, it worked. So if I run this, it'll run every time and ultimately get a winner and that kind of stuff. All right, so what I did, and here I can actually, let me save this and I'll share this current state of that code. That's on Slack. So my next step, as I mentioned last class, is now that we've built our back end, we've learned to play Connect 4 and apply the rules to it and stuff. Well, now we want to have a visible user interface for this thing. So what I did initially is I started off with download all files. So I downloaded those files to my computer into a folder, and then I ended up putting those files into my over in Unity. I put it into my scripts folder, into classes. So here's checker, here's our Connect 4 board. I actually didn't use this singleton. I was going to. Here's my game manager. Here's my move result. If you remember, move result was this guy, the thing that we got as a result of our move. So I brought all our stuff in from online GDB into here and then decided to strategically use it. So let's walk through the solution. So first of all, I'll show you the game running. All right, this. Right, so that's my starting position. So I just can move arrows so I can go as far left and as far right as I want, but it stops me eventually. As soon as I'm at the column I want, I hit space, it'll drop it down. Um, I can keep making my play. And there we have our winner. So that's the current way the game works. So let's talk about how we got to that point. All right. So I start off with my game manager here. And my game manager is serving two purposes. It is, first of all, the thing that has my script associated with it that actually plays the game for me. But it's also holds the position of where my checker starts when I first start the game. That invisible game object is the transform location of where my checker for making my move starts at. So kind of that upper left-hand corner, I just use that transform. I put that invisible game object in that position so I could use that for my location for my checkers. All right, so let's go into our game manager here and see what we're working with here. All right, so I have a couple of public variables, which is our way of handling MVC again, right? So I have a red checker and a black checker. What those guys were prefabs, which you've done before. So I created some very simple prefabs for a black checker and for a red checker. So these guys are effectively the same checkers as we had up there before. I just drug it out of there. But what I did is by default, I turned off the collider. And the reason I did that, just to kind of show you down the paths that this took us, when I make this move, do you see how that checker started off in that same place where I just hit space? When the next one shows up there before it starts falling, they interact with each other. So all of a sudden I have checkers falling all over the place because it knocked it offline and physics was taking over. So what I do is I don't actually turn on the collider until after the move has been made. So by default, they have their colliders turned off. That way they don't accidentally bump into other things until I'm ready for them to be able to bump into other things. All right, so I get my prefab for red checker and black checker. That way, well, depending on whose turn it is, I can create instances of those things. All right, so at the very beginning of the board of the game inside of start, I make my winning text invisible. That's just a text mesh pro that says winner. I make that invisible. I then add my checker prefabs to this array. So I have a red checker prefab, I have a black checker prefab, so that depending on whose turn it is, I can instantiate the right guy for that. Here's where we start connecting our Connect 4 up to it. So this used to be in main, right? Or it used to be maybe in our game player, the thing that had the play function in it or whatever. So I create an instance of our Connect 4 board. Now that Connect 4 board basically polices what I allow to have happen on here. So this is where we're dealing with our back end and our front end. All right, so I have my board. When I first start the game, remember start only gets called one time, I create the current checker, and he's going to be creating an instance of whichever checker prefab is associated with whoever's turn this is. This is that same thing we did before where we just mod it by 2 and keep adding turn. So 0 mod 2 is 0 remainder 0. 1 mod 2 is 0 remainder 1, 2 mod 2 is 0 remainder or is 1 remainder 0, so on and so forth. So it just toggles back and forth between my two prefabs. The position I'm putting it at when I bring it into existence is the position of the far left column. So if you notice up here, here are 7 X coordinates effectively. So as I'm running through my game, this guy's currently at X coordinate from bucket 0, bucket 1, bucket 2, bucket 3, back to bucket 2. Instead of adding something to it, instead of saying, okay, well, the distance between these guys is, let's say, 1.3, you start losing precision with floating point values when you're doing that. So if I'm doing math, eventually they get just far enough off where the checkers fall on top of the guy below it and start bouncing off in a different direction. So I'm making sure my drop locations are fixed. Here's bucket 0, here's bucket 1, here's bucket 2. So I'm always dropping it straight down from the same exact starting point. All right, and this is just going off of the left and right arrows here. All right, so that's what this guy holds into. This is just, I went in there and I just placed checkers at the places I thought the top of the column should be, and those are the X coordinates for those. All right. We have 7 columns, obviously. All right, so when the game first starts, I create my first checker. It is going to be a red checker since, you know, what I say, fire comes before smoke. Isn't that that's what we do in professional Connect 4, I guess. So I instantiate that very first checker at its starting location, you know, the place where I might drop it from, with the expectation I'm going to use arrows to move around until I pick the column I want to drop it onto. And then I have the space bar. When I hit that, it actually does the drop, assuming it's a legal move. And we're going to see that logic here in a minute. All right. Oh, this is an interesting thing here. When I was originally putting this in here, when I had my prefabs, when you moved into a prefab, what it does is it had the checkers laying horizontally. Yet I needed to give, when I bring it into existence, instantiate, puts it in the same thing that the original prefab was in, but I needed to fold it up. I needed to rotate it 90 degrees so it was facing me rather than laying down. Now, I think I referenced this a while ago when we first started talking about Unity. But in Unity, whenever we're dealing with rotations, it uses something called quaternions. Quaternions is they call it an advanced math thing. And quaternion-based mathematics is difficult. So this would be something that we would want to utilize the game engine to do that math for us so that we don't have to. And this thing right here is called Euler angles. So I'm telling my quaternion to create the right rotation angle for a 90 degree on X, no rotation on Y or Z. This produces the correct quaternion-based rotation for that guy. All right. Not something you need to be familiar with. Just anything you're dealing with rotations uses quaternions. Quaternions are weird. Use the built-in functions. That's the punchline. All right. So I get my current checker at the very beginning of the game. That's a red checker. I also get the rigid body for that checker because when checkers first come into existence, I have the rigid body's gravity, uses gravity turned off. That way it doesn't fall out of the sky until I'm ready for it to fall out of the sky. All right, so I bring the checker into existence. We go back here. So initially, that's the first state. This checker is instantiated at this location. And gravity by default, if I go down here to the rigid body, notice that use gravity is off. And also notice that my capsule collider is also currently disabled. Those are the two things that I have to turn back on once I'm ready to drop that checker. Dropping it requires gravity to start impacting again. And that capsule collider means that I want that on once it's cleared the tower so it doesn't interact with the next checker that you're going to place. I could have done this with delays and stuff too, but this was better. Okay, so I grab those in a couple. So I have two global variables, I guess. One is the actual checker, the game object for the checker that we created. And then I also have the rigid body for that guy. Probably should have also given myself the capsule collider to be consistent, but I grab it with get component later. So it's whatever. But those are the three things I need to know about. What's the checker I actually instantiated? Give me its rigid body, give me its collider so I can flip the switch when I need to. All right, so now on update. So every frame, I'm only allowing you to hit buttons and stuff, or I'm only caring if you hit buttons or stuff if the game is not over. Initially, game over is set to false. I also have a move count and I have a move position. Move count is the total number of moves that have been made. Move position is where it is on the columns, 0 through 6, to associate with these guys. Where do I want its X coordinate? All right, so inside of update, as long as there has not been a winner, as long as the game's not over, I ask the question, if you're hitting the right arrow on the keyboard, as long as the move position is still less than the number of columns minus 1. That means as long as there is a column to the right. That's what that's asking. If there's a column to the right of where I currently am, then increment my move position. So if I'm currently in this column, I want to increment my move position so the next X coordinate would be that guy. So I know where to move it to. But if I'm currently sitting here, there isn't something to my right. So I'm not going to get into that if statement. That's why it's the -1. I have to have at least one thing free to the right of me in order to get there. All right, so as long as I still have something to my right, increment the move position, set the position of the current checker. This is the checker I have not dropped yet. Current checker, set its position to a vector 3 whose X is whichever of those 7 values we had up here. Go ahead. Move position starts off at 0, and then as I hit the right and left arrow, it moves forward or moves back. So it goes from 0 to 6, depending on, it started off at 0. If I hit the right arrow once, it goes to 1. If I hit the right arrow again, it goes to 2. If I hit the left arrow, it goes back to 1. I use move position 0, 1, 2. So if I've hit the right arrow twice, I want my checker to appear at X coordinate minus 1.69. That's where it physically is located. So here, if I hit it twice, now move pause is currently a 2. Bucket, and notice here, if I click on my, yeah, I'm using move pause to keep track of which bucket of that array represents my X coordinates. So see how this guy says negative 1.69? The place in code where I'm doing it is right here. Here's my bucket of 7 column X positions, and here's me getting the value from that particular bucket from there. Well, for a vector 3, when you build a vector 3, this is the X coordinate, the Y coordinate, the Z coordinate. So X is going to be wherever it should be for that column. Y is 5.55. That's to make sure it's high enough on the screen. I put the checker there, decided, okay, I like that position, set it to 5.55. And Z, since everything, we're basically treating this as a 2D thing, Z is just, we're not doing anything with depth. So that's always going to be 0. All right, so I'm building a vector 3 for the location that I'm going to instantiate this. I want it to live here at this X, at this Y, at this Z, rotated 90 degrees. Brings it into existence. As long as the game's not over, if you've hit the right arrow, we'll let you go to the right as far as you possibly can. Each time through, we'll increment move pause. So we know which bucket of our array of X positions that it should place things. Then I'll take my current checker and I'll change its position to be that position at this Y height at this Z. That's what lets it move right and left. So basically, right arrow and left arrow do the same thing. It's just taking that guy on a voyage between 7 columns. All right. So those guys do the same thing. Then when I'm ready to make a move, once I have my thing hovered over the right location, so I've picked my column, I hit spacebar. When I hit spacebar, before it drops, I try to make the move. Because remember, in our boards make move, here's our Connect 4 board. Here is make move. We give it a column and we give it the color that is getting made. I'll come back to that. I start off with a blank move result. A blank move result has a success initially set to false. This is not a legal move until it becomes a legal move. So in my make move, I give myself an empty move result. Then I make sure that it's not an illegal column. Make sure the column is not full already. In either of those cases, if it's either an illegal column or it's full, I return the result that currently has false for success. Was not a successful move. Otherwise, if it's a legal column and the column was not already filled, then I go through and I update my information about my result to the success, the row it's going to, the column, all these things, the stuff we wrote previously. And then I return that. So when we're here inside of Game Manager, result here is going to be the result of trying to make that move. I'm only going to start doing things if that was a successful move. If it wasn't, if I tried to drop the checker on a, we can play to that. Here, I'll just start dropping it right here. So right now I have that column completely filled. I'm hitting the space bar over and over and over again, but that is currently a legal column, but it's already filled up. So that is not a legal move. Therefore, it's not going to let me drop anything. If I move to the right once and I hit space, now it'll let me drop. All right. So if I finally picked a successful move, picked a column where I can make a move, then what do? Well, first thing I do is I turn the capsule collider on. That way, if I don't turn that capsule collider on, then what ends up happening is this checker will fall right through the bottom floor. Because colliders interact with other colliders. Okay. Rigid bodies let us have mass and gravity. Colliders interact with colliders. Okay. So if this checker didn't have a collider, he would fly right through this guy because there's not two colliders to talk to each other. So I turn the checker's collider back on. Then I also turn the checker's gravity back on. I increment my move count because we have now made a successful move. I zero out move pause because the next checker is going to be up back at the upper left-hand corner again. That's where I'm going to be putting that guy. So he's going to be at bucket 0 of those X coordinates. And after that move has been made, then I start asking my board. So this is going back to the back end. I ask my board, is there a winner? Okay, so visually, I'm only dropping checkers. So my entire Unity game from a user interface perspective exists with left and right arrows, moving a instantiated checker and dropping it when it technically was a legal move. I don't have any logic in there related to what's actually happening on the interface. The interface only gets to make movements when the back end says they were okay to make, which is why it started getting frustrated when I was shifting and then all of a sudden my checkers started bumping into each other and things like that. But in any case, so if there was a winner, I turn his game over to true, so I don't respond to any more button presses. And then I enable my winner text so it says winner on the screen. Otherwise, I instantiate my next checker, which is going to be either a red or black checker, depending on what the current move count is. So if this is the first move, it would be a red checker. The second move would be a black checker. The third move would be a red checker, so on and so forth, using that same mod 2 trick. And its position would be at um, the far left position for my starting positions for my columns. I could have put move pause in here as well, but I know it's bucket 0. The same Y I used before, so on and so forth. Same Euler angle, 90 degrees. So I create my next checker. And we'll see here that if I stop this and I make my moves, it started off with a red checker. I make that move. The next guy's now a black checker because move pause just went, or move count just went from 0 to 1. 1 mod 2 is 0 with remainder 1. And what lives at bucket 1? My black checker. So that's why it's a black checker right now. When I make that move, now move pause has gone to 2. 2 mod 2, 2 goes into 2 0 times with 0 remainder. So now I get bucket 0 of that guy, which is the red checker. I make the next move. 2 becomes 3. 3 mod 2. 2 goes into 3 one time with a remainder of 1. We're back to the black checker. Flip-flopping back and forth. All right. So I get my next checker of the other color. I get its rigid body, so I can turn the gravity back on for that dude because the current rigid body is the checker I just placed. So I'm giving myself access to the new checker. Once I've let go of that guy and let him fall as far as he's falling, I don't need him anymore. He's visually done what I need him to do. Keep doing that over and over and over again until there is a winner. All right. So I didn't make any changes to move results. Move results is identical to what we had before. I don't even use Game Manager. This was what we had in our code before that has our play method in it. I'm not using that because that guy's the one who automatically played the game for us. Where in this case, I'm playing the game manually, right? In fact, I'm playing against myself, I guess. All right. So actually, I could take that guy out of there. I stopped this just to clean it up a little bit. Go into classes. Here's my game manager. I don't use that in here. That just happened from when I downloaded the entire thing off online GDB and I just dropped the files into my my scripts folder. But we see this guy still runs. All right. Move result had no change. My game manager CS, this guy's the one who's a mono behavior. So he's the one hanging off that empty game object in our scene who actually is playing the game. So this guy's taking the role of our other game manager. Core I never actually used. I was going to put the board up on core when I first did this in a singleton. And then I decided, well, since game manager is just doing everything with the board, I don't need to put it externally. He's the only one who needed access to the board. But if you did need to give someone else access to the board, you could put it up in core. My Connect 4 board didn't change at all either after I fixed the bug. You know, the bugs we had at the end of class last time. So, and checker didn't change either. So what we did is we wrote Connect 4 in its entirety over in online GDB. And then we just brought that entire back end, the checkers, the Connect Four board, and the move result over and used those things to behind the scenes keep track of what the actual state of our Connect Four board is, which should line up with what we visually see here. So after I make this first move, my two-dimensional array behind the scenes currently has a red checker at the bottom row on the far left column. Now he currently has a black checker in the whatever row and column that, well, bottom row, whatever column that was, so on and so forth. So we're visually seeing something here that behind our logic doesn't do anything with what we're seeing here. We're just using physics to make our board look amazing, let's say. You know, this is obviously high quality stuff. We're just using the physics engine to do that. The entire game is playing just like the text-based version of our game. Make some sense? So the goal of this lesson, let's say, is to show you that the difference between old school text-based video games and modern graphical video games is very little other than the user interface. Before, we used to make text-based menus or whatever for our user interfaces. Now we leverage button presses, or you could do mouse clicks if you prefer that, or, you know, whatever. So, you know, this user interface is a functional thing, but the logic actually exists behind the scenes. Does that make some sense? And I think that a lot of times when you start making more complex video games in tools like Unity, it is in your best interest to sometimes write it as a text-based thing first to get the logic working and not have to worry about all these game objects and the time it takes Unity to compile stuff and things like that. And then once you're confident that your logic is working, just bring that in there as the data structures that maintain the actual state of your game. And then all you have to do is make sure that your user interface at all times mimics what your actual state of your game is. All right, make some sense? All right, so now if we wanted to add some AI to this, what could we do? Well, we're going to go super simple random AI first. We could say, well, the player is going to make the move first. So we'll say the player is always the red checker. So when it's the computer's turn, he's going to randomly pick a column, right? And hopefully that's a legal move. And he'll keep randomly picking columns between 0 and 6 until he finally does make a legal move, is the concept there. So we have to go back into the code. We have to look at, we have to create an ability to know whose turn is it actually, to know whether or not we should be listening in update for the player to make a decision, or if it's currently the computer's turn and we need to wait for them to do their move. All right. It's going to happen pretty quickly because obviously, even if the computer needs to choose 4 different columns before it makes a legal move, that's going to happen real quick from our perspective. So the computer's always going to be good to go. We might have to put delays in if we want it to feel differently. But so let's go back into our code here. We'll go into Game Manager. We're going to go ahead and create a Boolean. Private bool is player turn. And when the game first starts, player goes first, so it'll be the player's turn. All right. So now what we want to do is inside of update, as long as the game is not over and this dot is player turn is true. So only if the game's still alive and the player's allowed to make a move do we do this. Otherwise, it's the computer's turn to make a move. Now, the computer can only make its move if it is if the game's not over either. So we might want to actually put this in a top level if statement and then put another if else inside of it. So we only do anything ever if the game's not over. Then, if it's the player's turn, we do all the stuff we used to do for the player's turn. All right, so nothing's changed there. I'm going to go ahead and minimize that. So if it's the player's turn, we do all the stuff we've already tested. Else, it's the computer's turn. Now I am going to quickly, we need to make sure that after the player has made their turn, we need to flip and say it's not his turn anymore. So I'll scroll down to this guy right here where it's the next guy's turn. Player made successful turn, but game is not over. That's what the deal is here. So we'll say this dot is player's turn is equal to false. All right. We'll go ahead and minimize this code here again. So here's our else. Didn't I already put an else in there? I did. So if it's the computer's turn, what are we going to do? We're going to randomly generate a column. So some number between 0 and 6. And I think we have an example of randomly generating stuff somewhere in here. Unity random number generator. Random dot range. Okay. Right, so we could say random dot range, and we want this to be a value between 0 and the number of columns. Do you remember, does it go all the way up to the number of columns or not including the number of columns? This dot numcols. All right, so we'll say int col is equal to that. We'll see through moves whether or not it never makes them, it never picks the last column or not. All right, so we want to keep getting a thing as long as our move is illegal. So we want to do something here, right? So we're going to say move result. Then we'll say do, because the computer needs to try to make a move at least one time. So we're going to use a post check loop, like a do while loop, instead of a pre-check loop, like a for loop or a while loop. So we're going to say do. We'll go ahead and get a random column. We'll then try to make that move. So we'll say result is equal to this dot the board dot make move. And we're basically doing the same thing we did. Player's turn, right arrow, space bars where we actually made the turn. Here's our move result. I'll just take that code there. So this dot the board, make move. It's going to be the same move position. Nothing's changed there. It's going to be the same color. Nothing's changed there. It's the computer's turn now, but it's equivalent to it being our turn just a few minutes ago. All right. And we're going to keep doing this while result.success is equal to false. So while not that. So when we get past this do while loop, we know result is a legal move by the computer? Now, all we've done is made the move behind the scenes. We haven't actually made our interface match up to that move. So now we need our interface to catch up to that move. Well, what do we do for that? Well, it's going to be basically the same thing that happened inside of our space bar here, where if it was success, we're going to take our current checker. We're going to do all these things we did before. And we really should probably put this in a function, but because we are strapped for time here. So if we had a legal move by the computer after we've randomly generated columns several times, we'll go ahead and turn the capsule collider back on, turn the gravity on, update the move count, set the move pause back to 0 for the next turn, check to see if there's a winner. If there is one, show the thing. We'll no longer come back and play another game. Otherwise, it will be the player's turn the next time. Regenerate the checker for the next turn, and turn the and get the rigid body for that guy. So with this logic now, we should be able to play against the computer, making complete random moves. Go ahead and make our move first. The computer makes real quick moves. All right, so then we'll let's work on a vertical win here. Is he still picking 0 every time? Do we have to, is it giving me a value between 0 and 1? My random number is not it's not working out correctly, although the computer did just beat us. All right, so a random number is giving us, so the way we guessed to make a random number was, where's my do while loop? I'm lost. Result. So random.range, this guy right here, he must not be giving us a number between 0 and 7. Since he's always giving me a 0 and we're putting it into an int, this guy's got to be giving me a value between 0 and 1, is, I guess, my feeling. So like something 0.9, if I try to put 0.9 into an int, it stores as a 0. If I try to put 0.1 into an int, it stores as a 0, so on and so forth. So I need a better random number solution to this. This indicates it should work this other way. No, whatever. All right, so we'll fix the random number thing and see our thing play. What we're going to talk about next time is the final exam, what stuff's going to be covered on it. And then we're going to go on and talk about how can we make our AI for this smarter. So between now and Friday, I won't make it an assignment, but if you want to consider how we can have a more targeted Connect 4 AI than just randomly picking columns, anything's going to be better than always picking column 0. But a random number generating thing, come to class Friday with that concept, and we can see if any of them seem implementable. All right, questions, comments, concerns, bribes. I will put up a link to my code in the scripts here in 10 minutes or something like that. I'll put it on Slack. I need to update it to GitHub. All right, I'll see everybody Friday.